Hey everybody, welcome to the Math Minute for Unit 4. In this unit, we're looking at a few different things, but I want to zero in specifically on the curve length formula. The algebra in this one really trips up a lot of students. So first I'm going to go quickly over the strategy and then look at a really common example that students tend to struggle with. So this formula can be a little bit overwhelming, but I really like to start within the root. Okay, so just focus on that one piece, and then we'll come back to the integral once we've come up with that and simplified it as much as we can. So first thing is I need to find that derivative of whatever function you're given. Then I need to square that and simplify it as much as I can. Then add 1 to it. And at that point, I've found everything that goes in the root. Okay, I'm going to simplify it as much as I can. And then I have really a choice of two things. I'm either going to factor it, or if I can't factor it, I'll try a u substitution and see if that works. Now, I really want to talk about that factoring strategy in this one, because the u substitution, it doesn't work out very often with these examples. So with factoring, the whole strategy is I want to be able to take that 1 plus the derivative squared, and I want it to simplify down to some binomial that's squared. That way, when I stick it in the square root, the square and the square root will cancel, and I just have a plus b, whatever that ends up being, left to integrate. So much easier than what we started with that square root. Okay, so let's look at a quick example of this. This is a really common one you'll see where I have some like x to a power, maybe there's a coefficient on there, plus 1 over some other power of x. So just like we said, I'm going to start by finding that derivative. Feel free to pause as you watch this video to verify my work. And then I'm going to square that out, remembering that I cannot just distribute the square. I have to actually FOIL it out. I have to distribute both terms in both binomials that I'm multiplying by each other here to get that, that trinomial at the end. And then I'm going to add 1 to that. And you'll see here that I've got a 1 and a negative 1/2 that I can go ahead and combine. So I get this here. And this is where you want to pause for a second and be glad that you wrote out all these steps, because what we want to notice is the similarity between what we have and what we had before we added the 1. These are almost exactly the same, except the 1/2 is now positive. And this is a pattern that's common. It's not a coincidence. Okay? You want to be looking for this when you're doing this type of example. So those are exactly the same, but that top one we got from squaring this binomial. And remember, my whole strategy here is to get a binomial squared to plug into my square root. So because they're almost the same except for the sign, that means that my new trinomial with the positive 1/2 should factor the same way, only with a positive. So it should look something like this. Okay, so this is a common pattern that you want to be looking for. So write out these steps, simplify in between so that you can see the relationship between these different polynomials. And now that I have that, I can go back to my factoring strategy, sticking that binomial squared inside of the root and simplifying it to have this nice binomial to integrate. I hope this helped with these types of problems. So good luck.